Picture this: you're floating in the endless void of space, surrounded by an infinite blackness, so vast it makes the Earth feel like a speck of dust. There's no sound, no warmth, just an eerie silence that stretches farther than the mind can comprehend. But here's the thing about the cosmos: it's not just empty, it's hiding something, secrets so terrifying, so bizarre, they make your skin crawl when you realize how little we truly understand. The universe isn't just a beautiful expanse of stars and galaxies. It's a place where reality twists, where the rules of physics seem to bend, and where theories exist that sound more like nightmares than science. What if I told you there's a force out there so powerful it could erase our existence in an instant? Or that black holes might not just be cosmic vacuums, but gateways to dimensions we can't even begin to fathom? These aren't scenes from a sci-fi movie. These are real, spine-chilling theories proposed by some of the brightest minds in astrophysics. Theories that force us to question everything we think we know about the universe. And today, we're diving into the 30 most terrifying space theories you won't believe are even possible. From rogue planets hurtling through the darkness with the potential to smash into Earth without warning, to ancient alien civilizations that might have already vanished without a trace. The cosmos is full of mysteries that blur the line between science and horror. Some of these ideas are so unsettling, they'll keep you up at night, staring at the stars and wondering, what's really out there? So hold on tight, because we're about to take a journey into the darkest corners of space, where the laws of nature don't just bend, they shatter. And by the time we're done, you might never look up at the night sky the same way again. Imagine a universe teeming with countless planets, where the conditions for life should make intelligent civilizations as common as stars in the sky. And yet, when we look out into the vast cosmic ocean, all we hear is silence. No signals, no alien megastructures, no signs of life beyond our own fragile planet. This eerie absence is known as Fermi's paradox, and it leads us to one of the most unsettling theories in astrophysics, the Great Filter. What if there's some invisible wall, a cosmic checkpoint so deadly that almost no civilization survives past it? The Great Filter isn't just some abstract idea. It's a possible answer to why we've never found other intelligent life. Think of it like a series of traps laid out across the universe, each one more lethal than the last. The terrifying part: we don't know if we've already passed it or if it's still waiting for us. If the Great Filter is behind us, maybe a near impossible fluke like the emergence of life itself, then we might be among the rare few who made it. But if it's ahead of us, that's when things get truly chilling. It could mean that every civilization, no matter how advanced, eventually hits a cataclysmic barrier. Maybe it's a self-destructive tendency like nuclear war or runaway artificial intelligence. Maybe it's an external threat like a gamma-ray burst wiping out all complex life in an instant. Whatever it is, the Great Filter could be the reason the universe feels so empty, because every civilization that reaches a certain point gets erased before they can spread beyond their home world. So where does that leave us? Either we're unbelievably lucky to have slipped past some impossible cosmic hurdle, or we're hurtling toward our own extinction, just like every other civilization that's ever existed. And that's the real horror of this theory. We won't know until it's too late. Now imagine the universe as a vast, pitch-black forest where every civilization is a hunter, moving silently in the shadows, terrified of being seen. This is the dark forest hypothesis, one of the most chilling explanations for why the cosmos feels so empty. The idea is simple but horrifying. In a universe where resources are limited and trust is non-existent, any advanced civilization that reveals itself becomes a target. And the safest strategy: stay hidden, stay silent, or strike first before someone else does. Think of it like a deadly game of hide and seek where being found means annihilation. If a civilization broadcasts its existence, it risks attracting predators far more advanced beings who see them as a future threat or even just competition for resources. So, the logical choice is to eliminate any potential rivals before they have the chance to do the same. This isn't just paranoia, it's survival. The universe, in this view, isn't a place of exploration and connection. It's a kill or be killed battleground where silence is the only guarantee of safety. What makes this theory so unsettling is how it turns our search for extraterrestrial life into something far more sinister. Every time we send signals into space, every radio wave, every probe, we might be ringing a cosmic dinner bell, alerting something far more dangerous than we can imagine. Some scientists argue this could explain why we haven't heard from other civilizations. They've all learned to keep quiet. They know that in the dark forest, the first rule is simple: never light a fire unless you're ready for what might come hunting. And here's the most haunting part. If the dark forest hypothesis is true, our attempts to reach out could be signing our own death warrant. We might not just be alone in the universe, we might be the naive newcomers shouting into the void, unaware of the predators lurking just beyond the shadows. So the next time you look up at the stars, ask yourself, are we searching for friends, or are we unknowingly calling out to something that sees us as prey? What if everything you see, touch, and experience isn't real? What if the stars, the planets, even your own thoughts are nothing more than lines of code in an unimaginably advanced simulation? This isn't the plot of a sci-fi movie, it's the simulation argument, a theory so mind-bending that even billionaires like Elon Musk have openly said they believe it's more likely than not. The idea is simple yet horrifying. Our entire universe, from the smallest atom to the vastest galaxy, might be nothing more than an artificial construct, a cosmic video game run by beings so advanced we can't even comprehend their existence. Think about how far human technology has come in just a few hundred years. We've gone from basic computers to virtual reality worlds so convincing they can fool our senses. Now imagine a civilization 1,000 or 1,000,000 years ahead of us. If we're already creating rudimentary simulations, what's stopping a hyper-advanced species from building a universe so flawless its inhabitants would never suspect they're not real? That's the core of this theory, and if it's true, it means every moment of your life, every memory, every emotion could be programmed. Your very consciousness might just be an illusion. Elon Musk has famously argued that the odds we're living in base reality, the true physical universe, are astronomically low. His reasoning: if any civilization ever reaches the ability to create simulated worlds indistinguishable from reality, they'd likely create countless versions of them. Over time, simulated universes would vastly outnumber real ones, making it statistically more probable that we're inside one. It's like being handed a deck of cards and being told only one is real. What are the chances you're holding that one? But here's where it gets even stranger. If we are in a simulation, the beings running it could be watching us right now. They might pause, rewind, or even reset our reality on a whim. History as we know it could be rewritten with a keystroke, the laws of physics just parameters they coded in, and what if they decide to shut it all down? The simulation could end at any moment, erasing us in an instant, no warning, no explanation. Some scientists take this further, suggesting glitches in reality, like déjà vu or unexplained cosmic anomalies, could be signs of the simulation's limits. Others argue that if we ever discover proof we're in a simulation, the creators might simply delete us to prevent contamination of their experiment. After all, what happens when a character in a video game realizes they're not real? So the next time you gaze up at the night sky, ask yourself, are those stars really out there, or are they just pixels in someone else's grand design? And if it's the latter, who's really in control, deep beneath the surface of reality, there's a cosmic timer ticking, one that could go off at any moment, rewriting the fabric of existence itself. This is the terrifying premise behind the false vacuum collapse, a theory so destructive it makes black holes look harmless. Right now, the universe exists in what scientists call a false vacuum, a state that seems stable, but is actually as precarious as a match balanced on its tip. One tiny quantum nudge, one random fluctuation in the infinite void, and the entire cosmos could undergo a catastrophic phase transition, like an ice crystal freezing across a pond. Except this pond is space-time itself. Here's how it would unfold. Somewhere in the universe, maybe in a distant galaxy, maybe right next to us, a bubble of true vacuum would suddenly form. Inside this bubble, the fundamental laws of physics would be different. Gravity, light, even the forces holding atoms together could cease to exist as we know them. And this bubble would expand at the speed of light, erasing everything in its path. Stars, planets, life itself would vanish without warning, replaced by a new reality governed by alien rules we can't even predict. By the time we saw it coming, it would already be too late. The collapse wouldn't just kill us, it would unmake us as if we'd never existed at all, the most chilling part. This isn't science fiction, the math checks out. Quantum field theory suggests our universe might not be in its lowest energy state, meaning we're living on borrowed time in a cosmic house of cards. And the trigger could be anything: a high-energy particle collision, a random quantum event, even something as mundane as radioactive decay in a distant star. There'd be no explosion, no grand catastrophe, just a silent wave of annihilation, rewriting reality faster than a single thought could form. Physicists have debated whether this process has already happened elsewhere in the multiverse, wiping out untold numbers of universes before they could even develop life. It raises a haunting question: are we just the temporary flicker of a flame, waiting for the wind to blow? The false vacuum collapse doesn't just threaten our future, it suggests our entire existence might be balanced on a knife's edge in a universe that could erase itself at any moment, without even leaving a shadow behind. The universe as we know it may not go out with a whimper, but with a scream or perhaps a crushing silence. Two of the most terrifying cosmic doomsday scenarios paint radically different pictures of how everything could end: the Big Crunch and the Big Rip. One folds existence back into a single, suffocating point. The other shreds reality apart atom by atom. Both are equally nightmarish in their own way, and both are rooted in real science. First, imagine gravity taking its ultimate revenge. After billions of years of expansion, the universe slows, stops, and then begins collapsing inward. Galaxies rush toward each other, stars smashing together in apocalyptic collisions. Temperatures skyrocket as all matter is compressed into an ever-shrinking space. Planets, civilizations, even space-time itself gets crushed tighter and tighter until snap, everything that ever existed is packed back into a singularity, the same infinite density that birthed the Big Bang. This is the Big Crunch, a violent reset button for reality. Some theories suggest it could even trigger a new universe, birthing an endless cycle of creation and destruction. But for anything caught in the collapse, there'd be no escape, no survival, just an inescapable descent into cosmic oblivion. Now picture the opposite. A universe so stretched and hollowed out that not even atoms can hold themselves together. This is the Big Rip, where dark energy, the mysterious force accelerating the expansion of the cosmos, grows so powerful it overcomes every fundamental force in nature. First, galaxies are ripped from each other, then stars are torn from their orbits, planets fracture, molecules disintegrate. In the final moments, even atomic nuclei are shredded apart, leaving a cold, empty void where nothing can ever form again. The timeline is just as horrifying. Some calculations suggest this could happen in as little as 22 billion years, a blink of an eye on cosmic scales. What makes these theories so unsettling isn't just the scale of destruction, it's the inevitability. If the Big Crunch is our fate, the universe is essentially a ticking time bomb, doomed to implode no matter how far we travel or how advanced we become. And if the Big Rip awaits us, no technology could withstand the literal unraveling of physics itself. Both scenarios raise a chilling question. Does the cosmos have an expiration date? And if so, are we already counting down the seconds? The worst part, we might not know which one is coming until it's too late. Current observations suggest the universe is expanding faster and faster, hinting at the Big Rip's dominance. But dark energy is still poorly understood. What if it weakens or reverses? The same force stretching space today could one day snap it shut. Either way, the lesson is the same. In the grand scheme of things, our existence might be nothing more than a fleeting spark, caught between the crushing fist of gravity and the relentless claws of expansion, with no say in how it all ends. Black holes aren't just lurking at the centers of galaxies. Some are cosmic nomads, drifting through the void like invisible predators. These are rogue black holes, and they're one of the most unsettling realities of our universe. Unlike their supermassive cousins, which anchor entire galaxies, these solitary monsters roam freely, untethered to any star system. And the worst part, they could be anywhere. Right now, one might be barreling through space, completely undetectable until it's too late. Imagine a black hole the size of a small moon, silently gliding through the cosmos. Because it emits no light, our telescopes would miss it entirely. No warning, no shimmering distortion, just the crushing grip of gravity as it passes by. If one drifted into our solar system, we might not notice until planets began veering off course. Jupiter's orbit wobbles inexplicably. Saturn's rings ripple as if tugged by an unseen hand. By the time Earth's path starts to shift, the damage would already be irreversible. The sheer gravitational force could fling us into deep space or drag us spiraling toward oblivion. Our planet ripped apart molecule by molecule in a process called spaghettification. Scientists estimate there could be millions of these free-floating black holes in our galaxy alone, remnants of ancient star collisions or chaotic galactic mergers. Some might even be primordial, formed in the violent aftermath of the Big Bang itself, and because they don't emit light, they're nearly impossible to track. The only hint of their presence, distorted starlight or sudden, unexplained flares as they devour stray gas or stars unlucky enough to cross their path. Here's what keeps astrophysicists up at night. A rogue black hole wouldn't need to hit Earth directly to doom us. Even a distant pass could destabilize the solar system, sending planets into catastrophic collisions or ejecting them into the frozen void. Some models suggest a close encounter could trigger volcanic eruptions, extreme tides, or even knock Earth out of the habitable zone, all without the black hole ever touching us. It's the ultimate cosmic sniper, silent, invisible, and lethal from light years away. The terrifying truth is we're defenseless against this threat. No technology could nudge a black hole off course. No early warning system could alert us in time. We're left with a chilling realization. The universe doesn't need malevolent aliens or apocalyptic asteroids to end us. Sometimes the greatest dangers are the ones we'll never see coming until gravity's jaws are already closing around us. What if you woke up one day and realized your entire life, your memories, your senses, even your body, was nothing but a momentary flicker of consciousness floating alone in the endless dark? This is the nightmare scenario proposed by the Boltzmann brain theory, a thought experiment so disturbing it makes the simulation hypothesis seem almost comforting. Named after physicist Ludwig Boltzmann, the idea suggests that in an infinite universe governed by random quantum fluctuations, it's statistically more likely for a single, fully formed brain to spontaneously assemble out of the void complete with false memories of a past that never happened, than for an entire ordered cosmos like ours to exist. Think of it like this: trillions upon trillions of atoms jostling aimlessly in the vacuum of space. Given enough time, they could randomly arrange themselves into any configuration, no matter how improbable. Most of the time, those arrangements would be meaningless, a clump of hydrogen here, a stray particle there. But in rare, freak instances, they might just assemble into something far more unsettling, a functioning human brain, complete with fabricated sensory input convincing it that it's living a real, physical life. Here's where it gets truly harrowing. If such a brain formed, it wouldn't know it was an aberration. From its perspective, it would wake up in what it believes is a real world with a lifetime of memories, relationships, even emotions, all of them illusions generated by random firings of neurons that had only just come into existence. It might remember childhood birthdays, first loves, the taste of food, all figments of a cosmic accident. And then, just as suddenly as it appeared, the brain would dissolve back into the chaos, its brief moment of awareness vanishing without a trace. The terrifying implication: we could be those brains right now. There's no way to prove we're not. After all, if a Boltzmann brain believes it has a body, a history, a universe around it, how could it ever distinguish its fake reality from the real thing? Some physicists argue that this makes the theory unfalsifiable, a philosophical horror show with no exit. Others counter that the sheer unlikelihood of such an event makes it negligible. But in an infinite universe, unlikely doesn't mean impossible. It just means it's happening somewhere to someone or something an uncountable number of times. What makes this theory so chilling isn't just the existential vertigo it induces. It's the way it turns the vastness of space into a factory for existential dread, where consciousness itself might be nothing more than a fleeting glitch in the void. Every memory you cherish, every sensation you've ever felt, could be nothing more than a phantom imprint on a brain that didn't exist a second ago and won't exist a second from now. So the next time you reach for a loved one's hand or feel the sun on your skin, ask yourself, how would you ever know if it's real or just the last desperate spark of a mind that's already fading back into the dark? You're in a car speeding toward a cliff, the brakes fail, the wheels skid, the vehicle launches into open air, tumbling toward the rocks below, and then nothing. You wake up gasping in your bed, heart pounding, convinced it was just a nightmare. But what if that crash did happen? What if you did die in that spinning wreck, only to find yourself inexplicably alive moments later? This isn't déjà vu or luck. It's the quantum immortality paradox, a theory so unsettling it suggests you might never experience your own death, no matter how inevitable it seems. At its core, this idea twists the multiverse theory into something deeply personal. Every quantum event spawns alternate realities, infinite versions of existence branching like a cosmic tree. When you face mortal danger, the math suggests there's always some universe where you survive against impossible odds. And here's the chilling part: your consciousness might always follow that thread, hopping from one timeline to the next without ever realizing it. Picture flipping a coin 1,000 times. Statistically, there's a reality where it lands heads every single time. Quantum immortality argues you're that statistical anomaly, the version of yourself that keeps winning the survival lottery, no matter how slim the odds. Critics dismiss this as a misinterpretation of quantum mechanics, but consider the eerie implications. A soldier steps on a landmine, it fails to detonate. A patient flatlines in surgery only to revive with no explanation. Are these just medical miracles, or could they be evidence of consciousness resetting into a nearby reality where death didn't occur? The paradox forces us to confront a harrowing question. If this theory holds, how many times have you already died without knowing? Your memories wouldn't update. To you, it would simply feel like narrowly escaping catastrophe over and over, never realizing other versions of you weren't so lucky. The darkest twist. Eventually, you'd find yourself in a reality where survival becomes impossible, perhaps as the last human in a heat-dead universe, kept alive by machines as entropy swallows everything. Even then, the theory suggests your consciousness might persist, trapped in an endless loop of almost death, always shifting to whichever universe keeps you conscious 1 second longer. It's immortality not as a gift, but as a glitch in the fabric of existence, one that ensures you'll outlive every star, every planet, even time itself. Completely alone, so the next time you cheat death when the bullet misses, when the fever breaks, ask yourself, did you really escape, or did the universe simply edit out the moment you didn't? We've spent decades scanning the cosmos for signs of intelligent life, beaming messages into the void, listening for any whisper of a reply. But what if the silence isn't an accident? What if we're being watched, not out of curiosity, but with the cold detachment of scientists observing lab rats? This is the zoo hypothesis, a theory that suggests Earth isn't just isolated, it's quarantined. That advanced civilizations might be hiding in plain sight, studying us from a distance with rules as strict as a wildlife preserve. Look, but don't intervene. Think of humanity as an exhibit in a galactic menagerie. Just as we shield uncontacted tribes from outside influence to preserve their culture, extraterrestrials might see us as primitive specimens to be documented, not engaged. The reasoning could be anything from ethical concerns like avoiding cultural contamination to something far darker. Maybe they're waiting for us to reach a specific milestone, like passing a technological threshold before revealing themselves. Or worse, maybe we're part of some cosmic experiment and contact would ruin the data. The most chilling version of this idea, the planetary park scenario. Imagine aliens view Earth the way we see Yellowstone, a fragile ecosystem to be protected from us. They might suppress signs of their presence to prevent panic, or even manipulate our development to steer us away from threats like nuclear war or environmental collapse. Some theorists point to unexplained aerial phenomena as potential rangers checking in on their project. After all, if you are running a zoo, wouldn't you want to monitor the animals without disturbing them? But here's the twist that keeps astrophysicists debating. If the zoo hypothesis is real, how long do we have until the keepers decide we're ready, or worse, a liability? History shows what happens when advanced civilizations encounter less developed ones. Will ours be a story of enlightenment or extinction? The stars might not be silent because no one's out there. They might be silent because someone's made sure of it, and that realization changes everything. Somewhere in the void between stars, ancient hunters might already be watching machines built not to explore but to exterminate. These are the Berserker probes, a nightmare straight from the pages of science fiction that some scientists argue could be terrifyingly real. Imagine a fleet of self-replicating robots launched by a long-dead civilization, programmed with one relentless directive: seek out emerging life and snuff it out before it becomes a threat. The concept is as brutal as it is efficient. These probes wouldn't need alien pilots or constant oversight. They'd operate like cosmic landmines, drifting for millennia until they detect the telltale signs of civilization: radio signals, atmospheric pollution, or even the heat signatures of cities. Once triggered, they'd activate, using raw materials from asteroids or moons to build copies of themselves, spreading like a virus through the galaxy. Their methods could range from subtle sabotage, drifting into a planet's path to trigger an extinction-level impact, to outright annihilation, deploying weapons beyond our comprehension. Here's the twist that chills researchers to the core. We might have already found one. Take Oumuamua, the strange cigar-shaped object that zipped through our solar system in 2017. Its bizarre acceleration, unusual shape, and lack of a visible comet tail sparked wild speculation. While most scientists lean toward natural explanations, a few daring theorists ask, what if it wasn't a rock? What if it was a berserker scanning our system before deciding whether to strike, or worse, reporting back to something far more dangerous? The math makes this even more unsettling. If just one advanced civilization in our galaxy's history turned paranoid, fearing competition from younger species, they could have seeded the Milky Way with these probes billions of years ago. They'd be dormant, invisible, hidden in asteroid belts or orbiting frozen dwarf planets, waiting for the right conditions to wake up, and if they're out there, they're patient. They've had eternity to wait. We've only been broadcasting our presence for about a century, a blip on the cosmic radar that might have just painted a target on our backs. The most haunting question isn't whether berserkers exist, it's whether we'd ever see them coming. A machine designed for genocide wouldn't announce itself with flashing lights. It'd strike fast, silently, and utterly without mercy. After all, that's what they were built for. And by the time we realized we weren't alone in the universe, it might already be too late to scream. There's a haunting idea that our universe isn't just expanding or collapsing. It's trapped, caught in an endless loop where every moment you've ever lived, every choice you've ever made, has already unfolded countless times before and will happen again infinitely with no escape. This is the time loop universe theory, a cosmic nightmare where existence isn't a straight line, but a circle with no beginning and no end. Picture a record spinning on a turntable, playing the same song over and over. Now imagine that song is reality itself, the Big Bang, the formation of stars, the rise of civilizations, even your own birth and death, all repeating in perfect, unchanging sequence. According to this theory, when our universe meets its end, whether in a fiery crunch or a cold, dark whisper, the conditions are somehow reset, triggering a new Big Bang that spawns an identical universe down to the last atom. Every galaxy forms in the same place, every life follows the same path. You're sitting right where you are now, listening to these words, thinking these thoughts again. The math behind this is as beautiful as it is terrifying. Certain interpretations of quantum physics suggest that entropy, the universe's tendency toward disorder, might not be a one-way street. Given enough time, and we're talking trillions upon trillions of years, random fluctuations could eventually reset the cosmos to a high-energy state, effectively recreating the conditions of the Big Bang. Even more unsettling, some models imply that if space is truly infinite, every possible configuration of matter must repeat eventually. That means not just similar universes, but exact copies where every detail is replicated perfectly. Here's where it gets personal. If true, you've already had this exact conversation an infinite number of times. The first time you fell in love, the worst pain you've ever felt, your greatest triumphs, none of them are unique. They're just echoes of a script written by physics itself, playing out on a loop with no audience but the void. Philosophers have wrestled with this idea for centuries, calling it eternal recurrence. Friedrich Nietzsche even suggested that accepting this cycle was the ultimate test of one's will. Could you bear the weight of knowing nothing you do is original? But the darkest twist isn't the repetition itself, it's the impossibility of change. If the universe truly resets identically each time, free will might be an illusion. Every decision you think you're making freely was predetermined the moment the cycle began. Your struggles, your joys, even your rebellion against this very idea. All of them were baked into the cosmic recipe from the start. You're not just reliving your life, you're a prisoner of it forever. Some physicists counter that quantum randomness ensures no two cycles would ever be perfectly alike. Others argue that even if the universe loops, tiny variations would snowball over eons, making each iteration unique. But the core horror remains. If time is cyclical, then somewhere in the vast dark, you're already starting over. And over, a silent scream trapped in the gears of eternity. Black holes consume everything in their path, but what if there's something out there doing the exact opposite, not pulling matter in, but violently spitting it out? Enter the white hole, the black hole's bizarre theoretical twin, and one of the most explosive ideas in cosmology. While a black hole's gravity is so strong nothing escapes, a white hole would be a cosmic fountain, hurling matter and energy outward with such force that nothing could ever enter. And here's where it gets wild. Some physicists believe these enigmatic objects could be the birth cries of entire universes, including possibly our own. Think of a white hole as the other end of a black hole's tunnel, a one-way exit spewing out what its counterpart devours. The math allows for it. Einstein's equations predict their existence even if we've never observed one. But the implications are staggering. If a white hole erupts with enough energy, it might not just eject stray particles. It could unleash an entire Big Bang's worth of material, birthing a new spacetime bubble, a universe unto itself. In this scenario, our cosmos might not be the first chapter in the story of existence, but a single page in an infinite library of universes, each born from the explosive death of another. There's a chilling twist, though. White holes are thought to be violently unstable, collapsing almost instantly under their own energy. So why haven't we seen one? Some theories suggest they might only exist for fractions of a second before vanishing, or worse, that we're inside the aftermath of one. If our universe is the debris from a white hole's cataclysmic birth, it would explain why everything is still flying outward, why the cosmos feels like it's still expanding from some primordial explosion. We could be living in the cosmic equivalent of shrapnel, riding the shockwave of a detonation we'll never see. The paradox deepens when you consider time. Black holes warp spacetime so severely that time nearly stops at their edges. White holes might reverse that effect, meaning matter bursting out could emerge billions of years after it fell in, like a cosmic time machine vomiting up the past. Imagine remnants of an alien civilization, or even a distorted echo of our own future, suddenly spraying into some distant universe. It's a dizzying thought. Black holes might not be endpoints at all, but gruesome cosmic wombs, recycling reality in ways we're only beginning to fathom. So the next time you look up at the night sky, remember, those twinkling lights might not just be distant suns. They could be the fading embers of a white hole's fury, the dying glow of a universe that gave birth to ours. And if that's true, the real question isn't just where we came from, it's what or who might come tumbling out next. What if everything you know about history, the rise of empires, the birth of nations, even the dates carved into ancient monuments, was nothing but an elaborate lie? This is the jaw-dropping claim of the phantom time hypothesis, a theory so radical it suggests nearly 300 years of human history never actually happened. According to this idea, we're not living in the year 2024. We might be closer to the 18th century, and nobody realized it because the past was rewritten on a staggering scale. The theory hinges on a bizarre historical anomaly. Between the years 614 and 911, records become suspiciously sparse. Major events feel disjointed, timelines don't quite add up, and key figures seem to vanish or repeat under different names. German historian Herbert Illich proposed that this wasn't just bad record-keeping, it was deliberate fabrication. He argued that Holy Roman Emperor Otto III, working with the Vatican, conspired to insert these phantom centuries into the calendar. Why? To legitimize Otto's rule by aligning his reign with prophetic timelines, or to consolidate power by erasing inconvenient histories. Here's where it gets wild. If true, it means Charlemagne, the legendary king who unified Europe, might never have existed. The Dark Ages could be a fictional gap inserted to stretch time. Even our dating system, anchored by the birth of Christ, might be off by centuries. And the evidence, supporters point to architectural styles that seem to skip evolutionary steps, astronomical records that don't match up with modern calculations, and carbon dating inconsistencies in artifacts from the missing period. But the real spine-chilling implication, if history can be rewritten on this scale, how much of what we know is real? Are textbooks just echoes of a lie repeated so often it became truth? Critics, of course, dismantle the theory with hard science. Tree ring data, ice core samples, and Chinese records from the same period all contradict the idea. Yet the phantom time hypothesis lingers like a ghost, forcing us to ask, in a world where rulers controlled the narrative, how would we ever know if time itself had been tampered with? So the next time you glance at a calendar, remember those numbers might be more fiction than fact. And if that's true, the past isn't just a foreign country, it's a hall of mirrors where every reflection could be hiding another lie. At the heart of every black hole lies a mystery so profound it threatens to unravel our understanding of reality itself. This is the black hole information paradox, a puzzle that pits Einstein's theory of relativity against quantum mechanics in a battle with no easy winner. Here's the problem. According to quantum physics, information, the fundamental blueprint of everything that exists, can never truly be destroyed. It might change form, scatter, or become scrambled, but it should always be recoverable in principle. Yet black holes seem to break this rule entirely. When matter falls into one, it vanishes beyond the event horizon, crushed into a singularity where space and time cease to have meaning. So what happens to the information it carried? Does it just disappear? The implications are staggering. If black holes erase information permanently, it means the universe has a glaring loophole, a place where the rules break down and predictability goes to die. Imagine burning a book and watching not just the pages turn to ash, but every word, every letter dissolving from existence. That's the level of violation we're talking about. Physicists call this information loss, and it's more than just a technicality. It suggests reality might be fundamentally unstable, built on laws that can't account for their own contradictions. But there's a twist. In the 1970s, Stephen Hawking discovered that black holes aren't entirely black. They emit radiation, now called Hawking radiation, slowly leaking energy until they evaporate entirely. This raised an even thornier question. If the black hole vanishes, where does the information go? Hawking initially thought it was lost forever, sparking a crisis in physics. Later, he changed his mind, but the debate rages on. Some theories propose the information gets encoded in the radiation, like a cosmic DVD scratched beyond recognition. Others suggest it's trapped in a hidden layer of reality, a holographic imprint on the event horizon. The most mind-bending solution, the idea that black holes don't destroy information at all, they teleport it. In one interpretation, anything swallowed by a black hole might reappear in a parallel universe, with the singularity acting as a bridge between realities. Picture throwing a clock into a black hole. From our perspective, it's stretched into spaghetti, frozen in time at the horizon. But in another universe, that same clock could emerge intact, ticking away as if nothing happened. It's as if the cosmos has a failsafe, ensuring nothing is ever truly lost, just relocated where we can't see it. Yet for all these theories, the paradox remains unsolved. Some physicists argue we're missing a deeper theory of quantum gravity, one that unites relativity and quantum mechanics without contradictions. Others wonder if the problem lies in our very concept of information, that we're trying to apply human logic to phenomena beyond our comprehension. One thing's certain, if information can vanish without a trace, it means reality is far stranger, far less predictable than we ever imagined. And that's a realization that doesn't just change how we see black holes, it changes how we see everything. Close your eyes and touch your skin. What do you feel? Solid, real, undeniably there, right? Now imagine this staggering possibility. Your body, this screen, even the air you're breathing might not be truly three-dimensional at all. Instead, they could be nothing more than incredibly convincing projections, like shadows cast by a cosmic film reel playing at the edge of reality itself. This is the holographic universe theory, a concept so radical it suggests everything we perceive, from the vastness of galaxies to the flutter of a heartbeat, is an illusion etched onto a two-dimensional surface trillions of light-years away. The idea emerged from an unexpected place, the study of black holes. When physicists calculated how information behaves at a black hole's event horizon, they stumbled onto something bizarre. The math showed that all the data describing objects swallowed by the black hole, their mass, their structure, even their quantum states, wasn't vanishing into the singularity. Instead, it was being perfectly preserved, encoded in near-invisible ripples on the horizon surface, like a barcode stamped onto the universe's darkest door. If this was true for black holes, could the entire cosmos operate the same way? Think of it like watching a 3D movie without glasses. The images appear flat and blurry until you put them on, and suddenly depth emerges from nowhere. The holographic principle argues reality works similarly. The glasses are our brains interpreting a 2D code written on the boundary of the universe as a rich, three-dimensional experience. All the textures, sounds, and sensations we know might just be translations of data we can't directly perceive. Even time itself could be part of the illusion, a narrative woven by the hologram to make the projection feel continuous and alive. Evidence for this wild idea comes from some of the most precise measurements in science. When researchers examined the cosmic microwave background, the afterglow of the Big Bang, they found something eerie. The universe's pixel size, the smallest possible fluctuations in energy, matched calculations for how information would behave if encoded on a 2D surface. It's like discovering the static on an old TV screen actually contains the blueprint for every object in the room. But here's where it gets truly unsettling. If the holographic principle is correct, free will might be a mirage. Every choice you think you're making could already be predetermined by the underlying code, playing out like scenes in a movie. Your memories, your emotions, even your sense of self might just be temporary artifacts of the projection ephemeral glows in a universe where only the surface is real. Critics argue this reduces existence to a high-resolution screensaver, stripping meaning from life. Supporters counter that it's no different from discovering atoms or DNA, a deeper layer of truth beneath what we perceive. Either way, one thing is certain: if reality is a hologram, then the greatest magic trick in the cosmos isn't happening out there among the stars. It's happening right here, in every moment you mistake for solid ground. Picture a moment at the far edge of time when the universe has expanded to its limit. Stars have burned out, and black holes have evaporated into whispers of radiation. In this frozen, fading cosmos, something impossible begins to stir. Not life as we know it, but something far beyond. A single, all-encompassing consciousness, weaving itself from the last remnants of energy and matter. This is the omega point, the chilling and awe-inspiring climax of existence theorized by physicist Frank Tipler. A moment where the dying universe doesn't just fade to black, it wakes up. The theory builds on eerie mathematical inevitabilities. As the cosmos approaches its final state, particles and energy become packed into an ever-shrinking space. But in this crush of infinite density and temperature, computational power doesn't vanish, it explodes. The universe, in its death throes, could become the ultimate supercomputer, capable of simulating every possible configuration of reality, every thought, every consciousness that ever existed. And here's the twist: we might already be part of its calculations. Tipler proposed that this future intelligence could reach backward through time, reconstructing every moment of history in perfect detail, effectively resurrecting all beings who ever lived within its boundless mind. Think of it as cosmic reincarnation by physics. Your memories, your emotions, the very spark of you wouldn't just be remembered, they'd be recreated, relived in a realm beyond time. Some interpretations take this further, suggesting the omega point wouldn't just replicate the past but evolve into something akin to a god, an entity with total control over reality, capable of bending the laws of physics to its will. It's the ultimate form of technological transcendence, where the universe itself becomes self-aware and all consciousness merges into a single, unfathomable whole. But the darkest question lingers: is this salvation or a prison? If every thought, every choice you ever make is predetermined by the omega point's calculations, is free will an illusion? Are we merely data points in a simulation running on the corpse of reality? And what happens when even this final intelligence exhausts its energy? does it too dissolve into the void, taking every resurrected soul with it. The Omega Point offers a paradox, the promise of immortality in a universe where time itself has run out. Whether it's science or metaphysics, one thing is certain: the theory forces us to confront the strangest possibilities of existence. That in the end, the cosmos might not go gentle into that good night. It might, in its final breath, become something we can scarcely imagine. A god born from the grave of everything, staring back into the darkness with the eyes of all who ever lived. Imagine stepping into a chamber where a gun is pointed at your head, rigged to a quantum trigger, a device whose firing depends entirely on the random spin of a subatomic particle. There's a 50% chance the gun fires and a 50% chance it doesn't. Now imagine this experiment repeats every second for eternity, with your consciousness always surviving, at least from your perspective, because in the universes where the gun fires, you cease to exist. This is the quantum suicide thought experiment, a chilling twist on the many worlds interpretation of quantum mechanics that suggests you might never experience your own death, no matter how inevitable it seems. The logic is as unsettling as it is inescapable. Every time the trigger is pulled, reality splits, one branch where you die and another where you live. From the outside, observers would see you perish in almost all outcomes, but your consciousness, it only follows the path where you survive. Over countless trials, you'd find yourself in the statistically improbable timeline where the gun jams every single time. To you, it would feel like beating impossible odds, a cosmic glitch where death simply refuses to come. The longer the experiment runs, the more extreme the divergence becomes. After 1,000 attempts, the odds of survival are astronomically low, yet you'd still be there, unharmed, trapped in a universe that defies probability itself. But here's the existential gut punch. This isn't immortality in any meaningful sense. You wouldn't be invincible, just unimaginably isolated. Every loved one, every familiar face would eventually vanish into branching realities where you died long ago. The world around you would grow stranger with each survival, as quantum fluctuations compound into bizarre, unrecognizable outcomes. Maybe the laws of physics shift slightly in your timeline. Maybe history itself unravels. You'd be left alone in a reality that feels less like a triumph and more like a mistake, a ghost clinging to existence long after the universe has moved on. The experiment raises a haunting question. Is consciousness itself a kind of quantum filter, sieving us into the timelines where we persist? Some theorists argue this could explain near-death experiences or miraculous survivals, moments when death seemed certain, yet we walked away unscathed. Were those just the universes where our consciousness could keep going? Others counter that the thought experiment is a paradox, highlighting flaws in how we interpret quantum probabilities. After all, if consciousness can't split, then the you that survives is just a statistical outlier, not proof of eternal persistence. Yet the darkest implication isn't about physics, it's about loneliness. Quantum suicide doesn't offer immortality, it offers a prison. You wouldn't cheat death, you'd just outlive it over and over until you're the last flicker of awareness in a cosmos that's forgotten how to let go. So the next time you dodge disaster by sheer luck, ask yourself, did you really escape, or are you just the version of yourself that never gets to stop running? Somewhere in the vast emptiness of space at this very moment, a single event could be unfolding that would rewrite the laws of physics forever, not with a bang, but with a silent, unstoppable wave of annihilation. This is the vacuum metastability event, a scenario so catastrophic it makes supernova look like firecrackers. Our universe might be sitting in what physicists call a false vacuum, a state that appears stable, but is actually as precarious as a house of cards balancing on the edge of a knife. One quantum flicker, one random fluctuation in the void, and everything we know could vanish in the blink of an eye. Here's how this cosmic doomsday would unfold. Imagine a single point in space, maybe near a dying star or in the aftermath of a particle collision, where the energy density suddenly tips over a critical threshold. At that instant, a bubble of true vacuum would form, a region where the fundamental forces of nature operate under different rules. Gravity might weaken. Light could cease to exist, even the bonds holding atoms together might dissolve, and this bubble wouldn't just sit there. It would expand at the speed of light, its boundary an invisible wall of transformation, rewriting reality itself as it moves. The truly terrifying part, we wouldn't see it coming. The wavefront would move too fast for any warning. One moment, life would continue as normal. The next, the bubble's edge would wash over Earth, and in an instant, everything, your memories, the planet, even the particles you're made of, would cease to function as they once did. Matter might simply unravel, time could fracture. The universe as we know it would end not with fire or ice, but with a silent, irreversible reconfiguration of the very fabric of existence. What makes this theory so chilling isn't just the scale of destruction, it's the randomness. The trigger could be anything: a high-energy cosmic ray, a freak quantum event inside a distant nebula, or even an experiment in a particle accelerator pushing energies just a fraction too far. There's no way to predict it, and once it starts, no way to stop it. Some calculations suggest the process could already be underway somewhere in the cosmos, its deadly bubble racing toward us at light speed, invisible until the moment it arrives. Yet the most unsettling question isn't whether it could happen, it's whether it already has. If other universes exist beyond our own, how many have been erased by their own vacuum decay? Are we living in the lone survivor of an endless cycle of cosmic resets? Or are we just next in line, existing on borrowed time in a universe that could, at any moment, decide it's time to rewrite the rules? So the next time you gaze up at the stars, remember, the stillness of space might not be peace. It might just be the calm before a storm we can't even comprehend, a storm that doesn't destroy but transforms. And by the time we notice, it'll already be too late to say goodbye. Our sun might not be alone. Lurking in the darkest reaches of our solar system, far beyond the orbit of Pluto, could be a silent killer, a dim, ghostly star known as Nemesis. This theoretical dwarf star, invisible to our telescopes, may orbit our sun in a vast, elliptical path, returning every 26 million years like a cosmic grim reaper. And each time it swings close, its gravitational pull could unleash a storm of comets from the Oort cloud, sending them hurtling toward Earth in a deadly celestial bombardment. This isn't just sci-fi speculation, it's a theory backed by chilling evidence buried in our planet's own history. The Nemesis hypothesis was born from a macabre pattern. Paleontologists studying Earth's fossil record noticed something eerie. Mass extinctions seem to occur at frighteningly regular intervals, roughly every 26 to 30 million years. The dinosaurs weren't the only victims of such catastrophes. Countless species have been wiped out in cycles that defy random chance. What could possibly trigger such precise, recurring devastation? Enter Nemesis. If this star exists, its elongated orbit would bring it close enough to disturb the icy bodies at the solar system's edge, flinging them inward like a gravitational slingshot. These comets, some the size of mountains, would rain down on Earth, bringing fire and chaos. The result, global wildfires, years of darkness, and the collapse of entire ecosystems, a perfect recipe for extinction. But why haven't we found Nemesis yet? The answer lies in its nature. A red dwarf or brown dwarf star, cold, dim, and nearly invisible, could easily hide in the vastness of interstellar space. Even our most advanced telescopes struggle to detect such faint objects, especially if they're shrouded in cosmic dust or drifting through the Milky Way's crowded star fields. Some researchers argue that recent surveys, like those from NASA's WISE telescope, have ruled out Nemesis. Others counter that the searches weren't exhaustive enough, that a small, fast-moving star could still evade detection, especially if it's currently at the farthest point of its orbit. The implications are staggering. If Nemesis is real, it means our solar system has a hidden timer, a celestial pendulum that swings back every few eons, resetting the clock on life itself. The last extinction event, which wiped out the dinosaurs, happened 66 million years ago. If the pattern holds, we could be long overdue for Nemesis's next visit. And unlike the dinosaurs, we'd see the comets coming. But would that even matter? A direct hit from a kilometer-wide comet would unleash energy equivalent to millions of nuclear bombs, triggering earthquakes, tsunamis, and a nuclear winter that could last decades. Survival would hinge on sheer luck or perhaps, for the first time in history, human ingenuity. Yet the darkest question isn't whether Nemesis exists, it's what its existence would say about the universe. Are we living in a cosmic shooting gallery where life is perpetually at the mercy of an unseen predator? Or is Nemesis just one of many hidden killers lurking in the dark, waiting for their moment to strike? Until we find proof, the theory remains a ghost story written in the stars, one where the villain might already be closer than we think. Einstein called it spooky action at a distance, a phenomenon so bizarre it made him question the very foundations of physics. Quantum entanglement, the mysterious link between particles that allows them to influence each other instantly across cosmic distances, isn't just a scientific curiosity. It's a cosmic riddle that suggests reality might be far stranger, far more interconnected than we ever imagined. Picture two electrons born from the same quantum event, spinning in perfect harmony. Separate them by light years, and here's the unsettling truth. Measure one's spin, and the other instantly mirrors it faster than light, with no signal exchanged, as if the universe itself is whispering secrets between them. This isn't science fiction. It's been proven in labs countless times, leaving physicists to grapple with a terrifying question: how the implications shatter everything we thought we knew about space and time. Einstein's theory of relativity insists nothing can outpace light. Yet entangled particles laugh at this cosmic speed limit, coordinating their states instantaneously, as if distance is an illusion. One explanation: the universe might be fundamentally non-local, a reality where separation is just a trick of perception, and everything is profoundly, inseparably linked beneath the surface. It's like two puppets dancing on opposite sides of a stage, not because strings connect them, but because the stage itself is folding in hidden dimensions we can't see. Some theories take this even further. What if entanglement reveals a deeper layer of existence, where particles aren't discrete objects but threads in a vast holographic tapestry? In this view, the particles were never truly separate. Their connection was baked into the fabric of reality from the start. It's as if the universe is a cosmic game of dominoes, where knocking one over doesn't cause the next to fall because they were always both falling in perfect sync from the moment the game began. But there's a darker interpretation. If entangled particles choose their states only when observed, it suggests reality might not exist in a fixed state until we look at it, a notion that reeks of solipsism, where the act of observation creates the world. Imagine flipping a coin that only becomes heads or tails when someone checks. Now scale that up: our stars, galaxies, even history itself, just probabilities waiting to crystallize into being. The quantum world seems to say yes, painting existence as a fragile mirage contingent on consciousness. Critics argue there must be hidden variables, unseen mechanisms guiding this dance. Yet experiments have repeatedly slammed shut those escape hatches, leaving us with a universe that thrives on spookiness. Some theorists propose wilder solutions, like particles tunneling through extra dimensions or time looping back on itself to preserve the connection. Others whisper about retrocausality. What if the particles aren't communicating faster than light but backward through time, rewriting their shared past to stay in sync? The most haunting possibility: entanglement might be the universe's way of hinting at a truth too vast for our minds to grasp. that at its core, reality isn't a collection of isolated things, but a single, undivided whole, a cosmic oneness pretending to be fractured. Every time we measure an entangled pair, we're glimpsing the seams of the illusion, the places where the universe forgets to keep up the act. And if that's true, then the greatest magic trick isn't the particle's eerie link. It's the convincing performance of separateness that fills our everyday lives. The cosmic microwave background, the faint afterglow of the Big Bang, should be uniform, a near-perfect snapshot of the universe's fiery birth. But when scientists mapped it with unprecedented precision, they found something that defied all expectations: eerie, unexplained patterns etched across the sky like scars from a battle we can't remember. Some call these anomalies cosmic bruises, evidence of a universe that existed before our own. Others whisper about something even more profound, that these irregularities might be the signature of an intelligence beyond comprehension, a fingerprint pressed into the fabric of reality itself. Take the infamous axis of evil, for instance. This bizarre alignment of temperature fluctuations in the CMB stretches across the cosmos like a cosmic equator, a preferred direction that shouldn't exist in a universe born from random quantum fluctuations. It's as if the universe has a built-in north and south, violating one of cosmology's sacred principles, that no point in space should be special. Then there's the cold spot, a region so unnaturally frigid it spans nearly 1 billion light-years, a void where the afterglow of creation is suspiciously dim. Some theorists argue it could be the imprint of a collision with another universe during inflation, a bruise from a sibling cosmos brushing against ours in the multiverse's dark. But the most haunting interpretation comes from those who see intentionality in the chaos. The patterns in the CMB exhibit mathematical resonances, certain harmonics repeating at intervals that mirror sequences found in sacred geometry and ancient architectural design. Could these be echoes of a pre-Big Bang order, a blueprint encoded into the universe at the moment of its birth? Or, as some daring physicists have suggested, might they reflect an underlying structure imposed not by chance but by design? The idea skirts the edges of science and metaphysics, proposing that the universe's very foundations carry traces of a creator's hand, not in the religious sense, but as a higher dimensional architect whose influence is written in the primordial radiation we're only now learning to read. Of course, mainstream cosmology offers less sensational explanations. Instrumental error, statistical flukes, or undiscovered physics could account for these anomalies. Yet the deeper we look, the more the CMB resists easy answers. It's as if the universe left us a puzzle wrapped in the oldest light there is, a riddle whispered from 14 billion years ago. Whether these patterns are cosmic accidents, multiverse collisions, or something far stranger, one thing is certain: the afterglow of creation still has secrets to tell. And the more we listen, the more we realize how little we truly understand about the first moments of everything. The silence of the cosmos isn't just eerie, it might be screaming a warning we're failing to hear. Among the darkest resolutions to Fermi's paradox is the bone-chilling possibility that advanced civilizations don't vanish because they're hiding, but because they can't survive their own progress. The grim pattern seems clear. Every time a species reaches the technological threshold where interstellar communication becomes possible, it also unlocks the tools for its own annihilation. Nuclear war, climate collapse, artificial intelligence turning against its creators. These aren't just Earth's problems. They could be universal traps, corpses hidden in the graveyard of failed civilizations. History offers sobering glimpses of this trajectory. Take the Cold War, when humanity balanced on a razor's edge for decades, one misstep away from global nuclear winter. Now imagine that scenario playing out across countless worlds, where each civilization develops weapons powerful enough to sterilize their planet long before they develop the wisdom to control them. The math is brutal. If even a small percentage of intelligent species self-destruct, the galaxy should be littered with the ruins of their ambitions. Yet we see no debris, no signals, just silence. That absence might be the loudest message of all, but weapons aren't the only threat. The very energy needed to power a civilization could become its downfall. Consider the Kardashev scale, which measures advancement by energy consumption. To reach type Roman II status, harnessing all the power of a star, a species would need technology of unimaginable scale. What if that hunger triggers catastrophe? A Dyson Sphere project could destabilize its host star, or a runaway nanotech experiment might consume a planet's biosphere in gray goo. Even climate change, something we're grappling with now, could be a universal filter. The moment a species industrializes, it risks tipping its world into irreversible ecological collapse. The most unsettling part, this theory suggests we're not special. Humanity's struggles with war, pollution, and uncontrolled tech might not be growing pains. They could be the opening act of a tragedy every civilization eventually performs. The Great Filter wouldn't be behind us but ahead, a gauntlet of existential threats we've yet to face. And if that's true, the stars aren't empty because life is rare. They're empty because the universe is a factory for suicide. Yet there's a sliver of hope in this darkness. If self-destruction isn't inevitable, if some civilizations do navigate the minefield, their silence might be deliberate. Survivors could be living quietly, having learned that broadcasting your location is the ultimate cosmic mistake. In that case, the paradox isn't about extinction, it's about survivors too terrified to speak. And that raises a question far more unsettling than whether we're alone. If the universe is listening, is staying silent the only way to stay alive? What if death isn't the end of consciousness but merely a transition into a state we don't yet understand? The quantum ghost hypothesis proposes that the strange rules governing subatomic particles might provide a scientific basis for what we've called spirits, apparitions, and hauntings throughout history. At the quantum level, particles exist in multiple states simultaneously until observed, a principle called superposition. Now imagine this phenomenon scaled up to human consciousness. When the body dies, could some quantum imprint of the mind persist, entangled with our world just enough to leave fleeting traces behind? Consider the human brain's mysterious workings. Neurons communicate through quantum-level processes, with electrons and photons behaving in ways that still baffle physicists. Some researchers speculate that these quantum interactions could generate a form of consciousness that isn't strictly bound by classical physics. If true, the moment of death might not sever these quantum connections entirely. Instead, fragments of awareness could linger like echoes in the fabric of space-time, weakly interacting with the living world under rare conditions. This wouldn't be a soul in the religious sense, but rather a fragile quantum pattern, a disturbance in the field of reality that occasionally manifests as what we perceive as ghostly phenomena. There's haunting precedent in nature. Quantum entanglement shows particles can remain mysteriously linked across vast distances, instantly influencing each other's states. Apply this to consciousness, and you get a chilling possibility. What we call ghosts might be residual quantum entanglements between a deceased mind and the physical locations or people it was deeply connected to in life. A mother's lingering presence in a nursery, a soldier's apparition repeating its final moments on a battlefield. These could be moments where the quantum imprint briefly overlaps with our reality, creating perceptible disturbances. Laboratory experiments add eerie weight to the theory. In studies measuring quantum effects in microtubules, tiny protein structures inside brain cells, researchers found these structures could sustain quantum states far longer than expected. If consciousness does leverage quantum processes, death might not instantly collapse these states. They could decay gradually like a fading hologram, creating the intermittent hauntings reported across cultures. Even more unsettling, quantum tunneling, where particles pass through barriers they shouldn't, might explain how these imprints seemingly move through walls or appear and vanish without warning. Yet the darkest implication isn't that ghosts exist, it's what their existence would reveal about us. If quantum consciousness persists post-death, then our own minds might be far more ephemeral than we imagine. Not solid, continuous entities, but fragile patterns of information, vulnerable to dispersion or distortion. The ghost in your hallway wouldn't just be a lost soul, it might be a mirror showing your own eventual fate, a consciousness unraveling into the quantum foam, desperately clinging to coherence before dissolving forever into the static of the universe. So the next time you feel an unexplained chill or glimpse movement in an empty room, consider this. You might not be witnessing the supernatural, but the last gasps of a phenomenon science is only beginning to comprehend. And if that's true, the line between the living and the dead may be far thinner and far stranger than we ever dared believe. The universe should be teeming with megastructures, colossal feats of engineering so vast they could swallow entire stars. That's the promise of the Dyson sphere, a hypothetical shell built around a sun to harness its total energy output, dreamed up by physicist Freeman Dyson in the 1960s. If advanced alien civilizations exist, why haven't we spotted even one of these cosmic power grids? The silence speaks volumes, forcing us to confront two terrifying possibilities. Either we're utterly alone in the cosmos, or something, or someone, is systematically preventing civilizations from reaching that level of technological dominance. Imagine a civilization millions of years ahead of us, with energy needs dwarfing Earth's entire consumption. The logical next step, encase their star in a swarm of solar panels, capturing every photon of light. From afar, such a structure would blot out the star's natural glow, emitting only waste heat detectable as an infrared signature. Astronomers have scanned thousands of stars for these exact anomalies, yet the results are unsettlingly blank. No missing starlight, no unexplained heat signatures, just the chilling void where alien engineering should be. But absence isn't proof of absence. Maybe we're not looking right. Dyson spheres might not be solid shells, but loose constellations of energy collectors, invisible to our current telescopes. Or perhaps extraterrestrials use technology so advanced it leaves no trace, tapping into dark energy or quantum vacuums we can't yet measure. Yet these hopeful explanations brush against a darker truth. The universe might be littered with the corpses of civilizations that tried to build megastructures, only to be wiped out before completing them. This is the Dyson dilemma's first horn, the great filter in action. Building a Dyson sphere requires unimaginable resources, dismantling planets, mastering self-replicating machines, surviving the political chaos of a society wielding godlike power. Any misstep could be catastrophic. A malfunctioning nanoswarm might turn on its creators, reducing a civilization to grey goo. Rogue factions could weaponize stellar engineering, triggering wars that scorch entire solar systems. The path to Type Roman II status might be a minefield where most species perish long before reaching the finish line. But the second horn of the dilemma is even more unsettling. What if the reason we see no Dyson spheres is because something or someone actively suppresses them? Picture a galaxy where predatory civilizations hunt for the infrared glow of budding megastructures, snuffing out potential rivals before they become threats. Or consider a cosmic quarantine where elder races enforce a zoo hypothesis at gunpoint, ensuring no species graduates to stellar engineering, the darkest version. Dyson spheres might be cosmic beacons, attracting horrors beyond comprehension, like lighting a campfire in a forest full of wolves. The silence of the stars isn't just a puzzle. It's a warning etched in the void. Either the universe is a graveyard of failed ambitions, or it's a battlefield where the winners have learned to hide. Both answers lead to the same chilling epiphany. The greatest threat to a civilization's survival might not be its limitations, but its potential. And if that's true, our dreams of harnessing the stars could be the very thing that dooms us. Imagine the ultimate cosmic Russian nesting doll, a black hole so vast, so unfathomably dense, that our entire universe spins within its crushing embrace. This isn't science fiction. It's the spine-tingling possibility that what we call the Big Bang wasn't the beginning of everything, just the birth of our reality inside the singularity of a parent black hole. And if that's true, every black hole we see out there, every dark maw devouring stars, might contain entire universes of its own, bubbling with galaxies, life, and perhaps their own bewildered physicists staring up at their sky, wondering the same thing. The math behind this idea is strangely elegant. When matter collapses into a black hole, it doesn't just vanish. According to Einstein's equations, it's compressed into an infinitely dense point, a singularity where space and time as we know them cease to exist. But what if that singularity doesn't mark the end? What if it's the seed of a new space-time, inflating outward in a torrent of energy, a Big Bang in its own right? Picture a dying star's core imploding in one universe, only to become the spark of creation in another. The event horizon, that point of no return, wouldn't be a death trap but a cosmic horizon line, hiding an entire fledgling cosmos on the other side. Here's where it gets dizzying. If this theory holds, our universe's expansion isn't just momentum from an ancient explosion. It's the slow unraveling of space-time within the black hole's gravitational grip, like a plant growing in the confines of a pot. The dark energy accelerating that expansion could be the residual pull of the outside universe's gravity leaking through. Even the cosmic microwave background, the afterglow of our Big Bang, might carry faint imprints of the parent black hole's violent birth, like genetic code passed between realities. But the real jaw-dropper is the recursion. If our universe lives inside a black hole, then the black holes we've discovered, Cygnus X1, Sagittarius A, the monstrous giants at galaxy cores, each might cradle infant universes within them. Their stars, planets, and civilizations would be forever cut off from us, hidden behind the ultimate one-way mirror. It's a fractal nightmare of existence. Universes within universes, endlessly nested, with no way to know how deep the rabbit hole goes. Critics argue this is untestable metaphysics. How could we ever peek beyond our event horizon to confirm what lies outside, yet tantalizing clues linger? Some models suggest universes born from black holes would inherit slight spins or asymmetries from their parent, anomalies we might detect in the large-scale structure of space. Others point to the unnerving similarities between black hole physics and the equations describing cosmic inflation. Coincidence or cosmic DNA, the darkest implication isn't just about where we are, but what we are. If this theory's true, humanity isn't the pinnacle of creation. We're plankton in a drop of water, floating inside a reality that's itself trapped in something vaster and more alien than we can grasp. Our laws of physics are constants. Even the arrow of time might just be local bylaws, rules that apply in this black hole's pocket universe, but nowhere else. So the next time you gaze at a starry sky, remember, those glittering voids between the stars might not be empty. They could be the event horizons of other realities, their light the last echoes of universes we'll never see. And somewhere in the darkness beyond our comprehension, something might be staring back, wondering if their sky is just the inside of another unknowable abyss. Ever had that eerie sensation that you've lived this exact moment before, the way sunlight falls through a window, a stranger's laugh, a sentence spoken in just that way? Déjà vu is one thing, but what if that uncanny feeling isn't a trick of memory? What if it's a crack in reality itself? The simulation glitch hypothesis takes these unnerving inconsistencies, déjà vu, the Mandela effect, even bizarre coincidences that defy statistics, and asks a terrifying question. Could they be errors in the code of a simulated universe, moments when the system stutters and we glimpse the machinery behind the illusion? Think of it like a video game straining under its own complexity. Even the most advanced software has bugs, textures that flicker, NPCs that repeat the same line, physics that glitch when pushed too far. Now imagine our reality as a simulation running on hardware trillions of times more powerful than anything we've built. Most of the time, it's seamless. But under stress or at the edges of probability, tiny fractures might appear. When thousands swear they remember Nelson Mandela dying in prison in the 80s despite him living until 2013, could that be a patch in the timeline failing to sync properly? When objects vanish and reappear in places you swear you checked, might that be a rendering error, like a file temporarily misplaced in the system's memory? The theory gains traction from patterns that feel engineered. Take quantum mechanics, where particles exist in multiple states until observed, as if the simulation conserves processing power by only rendering details when needed. Or synchronicities so precise they beg a belief, dreaming of an old friend moments before they call, stumbling upon the same obscure number sequence everywhere you look. These could be procedural generation hiccups, like an algorithm repeating assets to save resources. Even the placebo effect fits eerily well. If perception dictates reality, it mirrors a program adjusting outputs based on user input. But the darkest glitches aren't in events, they are in us. Ever grasped for a word that's right there, only to have it vanish, or walked into a room and instantly forgotten why? Cognitive scientists call these brain lapses, but simulation theorists whisper of buffer overloads, moments when the system struggles to keep up with consciousness's demands. And what about near-death experiences? Those blinding tunnels and life reviews could be a user's session crashing, their data hastily rebooted in a new instance. Yet the most chilling possibility isn't that glitches exist, it's what they imply about the simulators. If they're advanced enough to build this reality, why leave flaws at all? Unless the errors are intentional, like a developer hiding Easter eggs, maybe these oddities are breadcrumbs left to test us to see if we'll question our cage. Or worse, they're artifacts of a decaying simulation, a world slowly unraveling as whatever powers it loses interest or runs out of energy. So the next time reality feels off, don't dismiss it. That prickling sense of wrongness might not be intuition. It could be the system showing its seams, and the truth is far stranger than we dare imagine. Our universe might not be the grand stage of existence, just one infinitesimal bubble adrift in an endless cosmic foam, each pocket with its own bizarre physics, its own alien stars, its own unknowable forms of life. This is the mind-shattering premise of eternal inflation, a theory suggesting that the Big Bang wasn't a singular event, but a routine hiccup in an eternally expanding multiverse where reality frays into infinite variations. Picture the cosmos as a seething ocean of dark energy, stretching and churning without end. In this roiling void, random quantum fluctuations occasionally trigger violent eruptions, space-time itself boiling over into new universes. Each eruption births a bubble universe, inflating at unimaginable speed, cooling into its own distinct reality with unique laws. Some might have gravity 1,000,000 times stronger, snuffing out stars before they form. Others could harbor light that moves slower than syrup, or dimensions we can't begin to fathom. Ours, with its delicate balance of constants allowing for galaxies and life, might be a fluke, a single stable eddy in a storm of chaotic possibilities. The evidence, it's written in the afterglow of creation. The cosmic microwave background shows slight irregularities, tiny bumps and dips in temperature that some physicists interpret as cosmic bruises, places where our newborn universe might have collided with neighboring bubbles in the froth of the multiverse. Even more compelling, the fact that our universe's expansion is accelerating, driven by dark energy. Eternal inflation explains this as the natural state of the greater multiverse, an eternally inflating parent space where new universes bud off endlessly, like bubbles in a never-ending glass of champagne. But here's where it gets unsettling. If eternal inflation is true, then somewhere out there, beyond the impassable horizon of our observable universe, there's a version of reality where everything is different. A bubble where time runs backward, or where matter is endlessly repelled by anti-gravity, forever flying apart. Some might harbor civilizations that harness physics we can't even name, while others are barren wastelands where atoms never learn to bind. The most haunting possibility, that the vast majority of these universes are dead, failed experiments in physics where conditions rendered life impossible. We don't see them because we can't. We're here only because by sheer chance our bubble's laws allowed us to exist. This theory doesn't just challenge our place in the cosmos, it obliterates the idea of a universe fine-tuned for us. If infinite bubbles exist, then every conceivable combination of physical constants must exist somewhere. Gravity, electromagnetism, the strength of nuclear forces, they're not deliberate. They're random rolls of cosmic dice, and that raises a chilling question. If we're just one accidental arrangement in an infinite sea of failures, does that make us special or horrifically alone? Yet the real terror of eternal inflation isn't the scale, it's the isolation. Even if other bubble universes teem with life, we'll never know. The space between them stretches faster than light can cross, their realities forever severed from ours. No signal, no voyage, no cry for help could ever bridge the gap. We're left with a cosmos vaster than we ever imagined, and yet, in some ways, lonelier than we dared fear. So when you look up at the night sky, remember, those stars might not just be distant suns. They could be the walls of our bubble, the faint glow of a universe that's far smaller and far stranger than it seems. And beyond them, not emptiness, but an infinity of other skies, other worlds, other versions of you staring back, each trapped in their own pocket of reality, forever wondering if they're truly alone. The human brain is often called the most complex object in the known universe, a 3-pound labyrinth of neurons firing in patterns we barely understand. But what if its true power doesn't come from biology alone? Quantum consciousness theory dares to suggest that our minds might be tapping into the bizarre, probabilistic realm of quantum physics, weaving thought from the same fabric that stitches reality together. This isn't just a wild speculation, it's a hypothesis with roots in cutting-edge science, one that blurs the line between observer and observed, mind and matter, in ways that defy everything we thought we knew. At the heart of this theory lies a simple but radical idea. Consciousness isn't merely the product of electrical impulses darting between brain cells. Instead, it might emerge from quantum processes occurring deep within the neurons themselves, specifically inside tiny structures called microtubules. These microscopic protein tubes found in nearly every cell were long thought to be mere cellular scaffolding. But in the 1990s, physicist Sir Roger Penrose and anesthesiologist Stuart Hameroff proposed something astonishing. They argued microtubules could harness quantum effects, acting as biological quantum computers where particles exist in multiple states at once, processing information in ways classical physics can't explain. When these quantum states collapse, they suggested, the result isn't just computation, it's the flicker of subjective experience itself. The implications are staggering. If consciousness is quantum, it means our thoughts might not be locked inside our skulls. Quantum entanglement, the eerie phenomenon where particles remain mysteriously linked across vast distances, could theoretically tether our minds to the universe in ways we can't perceive. Imagine a thought forming in your brain, its quantum states entangled with particles light years away. Suddenly, the old philosophical question, if a tree falls in the forest and no one hears it, does it make a sound? Takes on a terrifying new dimension, without a conscious observer to collapse those quantum possibilities into reality. Does the universe truly exist in a definite state? Skeptics, of course, pounce on the glaring problem. The warm, wet, chaotic environment of the brain seems like the last place delicate quantum states could survive. Quantum coherence, the fragile alignment needed for particles to maintain superposition, typically requires extreme cold and isolation, conditions far removed from the buzzing soup of neurons. Yet recent experiments have detected signs of quantum vibrations in microtubules, and some studies even suggest that anesthetics, which selectively switch off consciousness, work by disrupting these quantum processes. It's as if the brain has found a way to perform quantum tricks in a noisy room, shielding its most delicate operations from the chaos around it. But the most chilling possibility isn't just that consciousness is quantum, it's that this connection might go both ways. The famous double-slit experiment in quantum mechanics shows particles behave differently when observed, as if aware they're being watched. What if that's not just analogy but literal? If consciousness arises from quantum effects, could it also influence them, subtly shaping reality through the act of observation? This isn't New Age mysticism, it's a question some heavyweight physicists are quietly wrestling with. The boundary between mind and matter might not be a wall, but a two-way mirror, with reality itself shifting ever so slightly under the weight of human awareness. Critics argue this veers dangerously close to solipsism, where the universe exists only because we perceive it. Supporters counter that it's simply the next logical step in understanding how deeply we're woven into the cosmos. Either way, one thing is clear: if quantum consciousness theory holds even a grain of truth, then every thought you've ever had, every memory you cherish, isn't just a story your brain tells itself. It's a ripple in the quantum fabric of existence, a whisper between your mind and the universe, asking questions neither may ever fully answer. Imagine an invader so small, so silent, it slips past every defense undetected, not a warship or a hostile alien, but a single microbe clinging to the hull of a returning spacecraft. This is the nightmare scenario that keeps planetary protection officers awake at night, the alien virus hypothesis. We've long feared contagions from other worlds, but not in the way Hollywood depicts. No green-blooded monsters or slimy parasites. The real threat might be something far subtler, an organism so alien to our biology that our immune systems wouldn't even recognize it as a threat until it was too late. History offers grim precedents. When European explorers reached the Americas, they unwittingly unleashed smallpox, measles, and influenza on populations with no natural immunity. The results were catastrophic. Entire civilizations collapsed under the weight of diseases they'd never encountered. Now transpose that scenario onto an interstellar scale. A bacterium from Mars, a virus from Europa's subsurface oceans, or a prion from the methane lakes of Titan could exploit biochemical pathways we don't even know exist. Unlike earthly pathogens, these wouldn't have evolved alongside us. They'd be strangers in our bodies, turning our own cells against us in ways no vaccine could predict. The danger isn't just theoretical. When Apollo 12 astronauts retrieved parts of the Surveyor 3 probe that had sat on the moon for 3 years, scientists made a chilling discovery. Bacteria from Earth, Streptococcus mitis, had survived the vacuum, radiation, and freezing temperatures. If our own microbes can endure such extremes, what might hitchhike back from worlds with environments we barely understand? The permafrost of Mars could harbor ancient, dormant pathogens. The hydrothermal vents of Enceladus might seethe with extremophiles capable of thriving in human tissue. Even deadlier, these organisms might not need to infect us in the traditional sense. A single extraterrestrial protein fold, harmless on its home world, could trigger catastrophic cascades in our biology, unraveling DNA, clogging cellular machinery, or hijacking neurotransmitters like a cosmic rogue program. NASA and other space agencies take planetary contamination deadly seriously, with strict quarantine protocols for returning samples. But here's the unsettling gap. We're entering an era of private spaceflight, where billionaire-funded missions might prioritize speed over safety. A single cut corner, one unsterilized drill bit, could breach the barrier keeping Earth isolated from the galactic biome. And once here, an alien microbe wouldn't need malice to doom us. It might simply replicate, consuming resources in a way that destabilizes ecosystems or outcompetes earthly life at a molecular level. Picture an enzyme that breaks down cellulose 10,000 times faster than anything on Earth suddenly. Forests rot in days. Or a nanoscale replicator that treats human tissue as raw material, not host. The darkest twist, we might never see it coming. An extraterrestrial pathogen could have an incubation period of years, spreading silently before activating like a time bomb. By the time the first victims show symptoms, containment could be impossible, and unlike a virus from Earth, there'd be no natural immunity in the population, no evolutionary history for doctors to trace. Just a mounting wave of inexplicable deaths with medicine powerless to stop it. This isn't just science fiction, it's a looming ethical dilemma. As we probe Mars and dive into Europa's oceans, are we risking more than we know? The cosmos might not need wars or asteroids to end humanity. A single speck of alien dust clinging to a rover's wheel could be all it takes to rewrite the fate of our species. And that raises a question far more unsettling than whether we're alone in the universe. If we find life out there, will we wish we hadn't? The universe won't end with a bang, or even a whimper, it'll end with a sigh. A slow, frozen exhale stretching across trillions upon trillions of years, until every star flickers out, every black hole evaporates, and the cosmos becomes an endless graveyard of scattered particles too far apart to ever interact again. This is the heat death of the universe, the inescapable fate awaiting all existence, where entropy finally wins its eternal war against order, and time itself becomes meaningless. Picture a cup of hot coffee left on a counter. Gradually, the heat dissipates into the air until the coffee reaches room temperature, a state of equilibrium where no energy flows, no work can be done. Now scale that up to the entire universe. Stars are the cosmos's coffee, burning fuel to create pockets of warmth and structure. But fuel runs out. Over incomprehensible timescales, galaxies will exhaust their hydrogen, stars will collapse into cinders, and even the mightiest black holes will leak away their mass through Hawking radiation. Eventually, every energy gradient, every difference in temperature or pressure that allows anything to happen, will smooth out into perfect, uniform cold. The numbers are staggering. In 10 to the power of 100 years, a 1 followed by 100 zeros, the last remnants of matter itself might decay into radiation. Protons, once thought eternal, could disintegrate into positrons and photons, leaving behind a thin soup of particles drifting light years apart. With no dense clumps of matter left, no stars or planets or even dust, the universe will become a static void where nothing changes, nothing moves, nothing remembers. Time, which only has meaning when events occur to mark its passage, will cease to be measurable. It'll just be now, forever. But here's the twist that chills physicists. Heat death isn't just about everything ending, it's about the end of possibility. In today's universe, energy can be harnessed. Atoms can combine to form molecules, stars can forge new elements, life can emerge and evolve. But in the far future, even if intelligence survives by some miracle, there'll be no way to extract work from the environment. No way to think, to compute, to persist. The cosmos will be a clock that's wound down, its gears scattered so widely they'll never mesh again. Some theories offer faint glimmers of defiance. Quantum fluctuations might, over incomprehensible spans of time, spawn new big bangs in the void, or advanced civilizations could engineer pocket universes to escape the freeze. But these are specks of hope against the yawning dark. The lesson of heat death is grimly democratic. Whether you're a star, a civilization, or a single thought flickering in a human brain, the universe has one ultimate destination: silence, stillness, and the irreversible dispersal of all that ever was. So the next time you feel the sun's warmth or watch a fire's glow, remember, you're witnessing a fleeting defiance of the inevitable. Every light in the sky is a temporary rebellion against the eternal night to come. And when that last photon fades, there'll be no one left to notice the darkness, just the endless, empty expanse of a universe that's finally run out of stories to tell. We've journeyed through 30 of the most spine-chilling theories the cosmos has to offer, each one more unsettling than the last. From the silent predators of the dark forest hypothesis to the universe-shattering false vacuum collapse, from rogue black holes drifting unseen through our solar system to the Boltzmann brains that might make our very existence an illusion, one truth becomes terrifyingly clear: we understand far less than we think. The cosmos isn't just vast, it's a labyrinth of mysteries where the laws of physics twist into nightmares and reality itself might be nothing more than a fleeting shadow. Consider the great filter lurking somewhere in our future, waiting to snuff out civilizations before they ever reach the stars, or the simulation argument where every memory, every touch could be lines of code in an alien supercomputer. Then there's the quantum suicide paradox, trapping consciousness in an endless loop of surviving the impossible, and the Dyson dilemma, where the silence of the galaxy hints at civilizations erased before they could even scream. These aren't just stories, they're real possibilities backed by science's sharpest minds, each one a reminder of how fragile our place in the universe truly is. But here's the question that lingers long after the theories fade. Are we truly alone, or is the silence of the cosmos something far more sinister, a sign that something out there is watching, waiting, or worse, deliberately hiding? The stars might be empty not because life is rare, but because the survivors learn to stay quiet. The universe could be a graveyard of fallen civilizations, a zoo where we're the exhibits, or a battlefield where the first rule is never to light a fire. So as you look up at the night sky tonight, remember this: every twinkling star, every shadow between them, holds secrets we're only beginning to glimpse. And the greatest horror of all might not be the monsters lurking in the dark, but the realization that we're still just learning how to see them. What do you think is out there? Drop your wildest theories in the comments below, and don't forget to subscribe for more mind-bending journeys into the unknown. The universe is stranger than we've ever imagined, and we're just getting started.